Space, boundless, breathtaking, and bursting with possibilities. Humanity's desire to explore its depths goes back generations. But even now, the biggest question in space travel remains, how can we get there faster? Current rocket technology, while incredible, is still limited by fuel efficiency, travel time, and the simple fact that space is vast. But scientists and engineers are working on two groundbreaking solutions, ion propulsion and nuclear engines, that could change everything. Let's start with ion propulsion, a technology that sounds more like science fiction than science fact. Unlike traditional chemical rockets that use combustion to force exhaust gases out and create thrust, ion propulsion relies on electricity. Here's how it works. An ion propulsion engine generates ions by removing an electron from a neutral atom, typically xenon. These ions are then accelerated by an electric field and shot out of the engine at extraordinary speeds, up to 10 times faster than what you'd see with the exhaust of a chemical rocket. The result? A small but incredibly consistent thrust that adds up over time, allowing spacecraft to reach phenomenal speeds. Ion propulsion engines are perfect for long-duration missions. They don't consume large amounts of propellant like traditional rockets, which means they can carry less fuel and more scientific equipment or payloads. That's where nuclear engines come in. Imagine harnessing the raw power of nuclear energy to revolutionize space travel. NASA has already deployed this technology in groundbreaking missions like the Dawn spacecraft, which explored the asteroid belt. Ion propulsion is efficient, reliable, and ideal for deep space exploration. But its low thrust means it's not suitable for launching spacecraft off Earth, at least not yet. As we continue to develop these technologies, the potential for faster, more efficient space travel becomes more tangible. The stars are closer than ever. That's where nuclear engines come in. Imagine harnessing the raw power of nuclear energy to revolutionize space travel. Unlike ion propulsion, nuclear engines are being developed with the goal of combining both high thrust and efficiency. These engines fall into two main categories: nuclear thermal propulsion and nuclear electric propulsion. In nuclear thermal propulsion systems, a nuclear reactor heats a propellant, usually hydrogen, to generate thrust. Because nuclear reactions produce far more energy than chemical ones, this type of engine could cut travel times to Mars in half or even less. Then there's nuclear electric propulsion, which merges nuclear energy with ion thrusters, using a reactor to generate electricity to power an ion propulsion system. It's the best of both worlds, nuclear efficiency fueling the speed and precision of ion technology. The potential applications of these technologies are staggering. Faster interplanetary travel could lead to human colonies on Mars, mining operations on distant asteroids, and robotic missions to explore the moons of Jupiter and Saturn, all within decades instead of centuries. Both NASA and private companies like SpaceX are investing heavily in experimental designs to make these futuristic engines a reality. So what does the future hold for space travel? With ion propulsion offering unparalleled efficiency and nuclear engines promising powerful thrust for long-haul missions, humanity stands on the cusp of an interstellar revolution. These future-facing technologies aren't just rethinking how we explore space, they're redefining the very limits of possibility. The stars are closer than they've ever been, and one day, thanks to these innovations, our journeys into the cosmos could be faster, safer, and more daring than we ever imagined.